Modern firefighting depends on highly specialized machines. Today's video, we're going to take a look at 15 of the most advanced fire trucks in the world. Starting with number 15, the Rosenbauer Panther ARFF in Austria. The Rosenbauer Panther is one of the most advanced firefighting vehicles ever produced and is regarded as the benchmark for modern airport rescue and firefighting. Manufactured by the Austrian company Rosenbauer, the Panther is used at major international airports all over the world, including hubs in Europe, North America, Asia, and the Middle East. Its design is focused on one purpose above all others: delivering enormous firefighting capability at very high speed in the critical first minutes of an aircraft emergency. The Panther is built on a purpose-designed chassis rather than any modified commercial truck. It's available in 4x4, 6x6, or even 8x8 configurations, which allows the airports to select versions based on runway size. Depending on the configuration, it can carry between 12,000 to 19,000 liters of water, along with several thousand liters of foam concentrate and dry chemical powder. Despite weighing more than 30 metric tons when fully loaded, the 8x8 version can accelerate from 0 to 80 kilometers an hour in under 25 seconds and reach top speeds exceeding 110 kph. That performance is mandated by international aviation standards, which require these vehicles to reach the farthest point of an airport runway with a strict time limit. The roof-mounted turret, that's known as the RM80 or RM60 depending on the config, can deliver water or foam at rates exceeding 9,000 liters a minute. The front bumper turret provides additional close-range suppression, particularly useful on approach or when maneuvering near an aircraft fuselage. The cab is constructed with reinforced materials and is certified for rollover protection. It includes some advanced thermal insulation and heat-reflective glass, and some configurations also feature infrared or thermal imaging cameras, which gives the crews visibility through smoke and low-visibility conditions. Critical systems like pumps, electronic controls, and drivetrains are engineered to continue operating even if parts of the vehicle are damaged, and that reflects a real-world airport scenario where debris, heat, and fuel explosions can compromise equipment within seconds. Now, while the Panther is extremely capable, it's not intended for urban firefighting or routine structural fires. Its size and operating costs do limit it to airports and certain military installations. But even so, its influence on firefighting vehicle design has been substantial. It's pushing the industry towards higher automation, better crew protection, and faster response times. Number 14, the Magirus M32L AS. The Magirus M32L AS turntable ladder is one of the most advanced firefighting vehicles used in urban environments. Produced by Magirus, a German manufacturer with firefighting roots that date back to the 19th century, this ladder truck represents the high end of modern fire apparatus. It's widely used by professional fire brigades across Europe, particularly in cities where height, density, and narrow streets demand reach. The ladder has a maximum working height of about 32 meters, which allows firefighters to access upper floors of mid- and high-rise buildings that would otherwise be unreachable by ground crews. One defining feature is the fully articulated ladder. The ladder sections can extend, retract, and rotate with a high degree of precision, even in confined urban spaces. Their computer-aided stability control system will continuously monitor load, angle, and extension to ensure the ladder operates within safe limits. If unsafe conditions are detected, that system will automatically restrict movement to prevent tip-over or structural overload. The rescue cage mounted at the end of the ladder is designed for both firefighting and evacuation. It can carry multiple people at once, and it's equipped with control panels that allow firefighters in the basket to reposition it independently. Its integrated water and foam delivery system allows the crews to direct fire streams from height, reducing the need to position firefighters directly inside a dangerous structure. The cab and control systems emphasize ergonomics, and operators will use touchscreen interfaces and joystick controls rather than manual levers. Systems are continuously monitoring hydraulic pressure, the ladder stress, and the system health, and they'll alert crews to maintenance needs before failures even happen. And these features are designed to increase its reliability during extended incidents. This vehicle is focused on proven firefighting principles rather than experimental tech. There's no automation here of decision-making or remote operation beyond the established safety functions, but where documentation doesn't specify exact performance limits under all conditions, the departments will rely on standardized training and operational guidelines rather than assumptions. This isn't the tallest ladder truck in the world, nor is it the largest, but what makes it advanced is the way it integrates its strength, its digital controls, and its practicality into a single platform. It is designed to operate every day in real city conditions rather than rare or extreme scenarios. Number 13. The Oshkosh Striker. The Oshkosh Striker, ARFF, it's one of the most advanced airport firefighting vehicles in active service, and it's a direct counterpart to the European ARFF trucks like the Rosenbauer Panther. It's manufactured by Oshkosh Airport Products in the U.S. The Striker is used at major commercial and military airports all over the world, and its design is driven by aviation safety standards. It's available in 4x4, 6x6, and 8x8 configurations, and that allows airports to tailor the vehicle to the runway length and aircraft size. And depending on configuration, it can carry about 17,000 liters of water, along with foam, concentrate, and dry chemicals. That multi-agent capability is needed for aviation fires where burning jet fuel, composite materials, and even magnesium components may all be present simultaneously. But even at full operational weight, the vehicle is designed to accelerate rapidly and maintain high speeds across the runway. Its firefighting systems are controlled electronically. They're integrated into the vehicle's central control. Roof-mounted turrets will deliver water or foam at rates exceeding 9,000 liters a minute, while the bumper-mounted nozzles provide close-range suppression during an approach. Operators can control these systems from inside the cab using joystick controls and digital displays. Crew safety, of course, is a major design priority. The cab is reinforced and certified for rollover protection and impact resistance, and optional thermal imaging cameras provide visibility through smoke and in the darkness. Critical systems like the pumps, the drivetrains, and electronics, they're all engineered to continue operating even if parts of the vehicle are damaged. And that reflects a real-world aircraft emergency where debris, heat, and explosions will compromise equipment almost immediately. While the Striker is among the most capable vehicles, it's also very highly specialized. The size, weight, and operating cost limited almost exclusively to airport and military use, since it's not intended for municipal firefighting, where maneuverability in tight streets are more important. In operational terms, though, the Oshkosh Striker is one of the most advanced fire trucks in service today. Number 12. The Rosenbauer RT Electric Fire Truck. The Rosenbauer RT, it is one of the most advanced municipal trucks currently in production. It represents a significant shift in how fire apparatus are designed and powered. Developed by Austrian manufacturer Rosenbauer, the RT is short for Revolutionary Technology. It is the world's first fully electric fire truck to enter regular operational service with professional fire departments. Unlike traditional fire engines that adapt commercial truck chassis, the RT was designed from the ground up. It uses a battery electric drivetrain supported by a range-extending generator, allowing it to operate silently and emission-free. This hybrid electric architecture was developed specifically to meet the unpredictable duty cycles of firefighting. With independent electric motors and all-wheel steering, this truck can execute extremely tight turns, making it well-suited for a dense environment in an urban area with a narrow street. The low-mounted battery system also lowers the vehicle's center of gravity, which improves stability during high-speed response. The RT will carry standard water and foam, along with full structural firefighting equipment, and its electric pump drive allows precise control of pressure and flow while reducing any mechanical complexity to the machine. According to Rosenbauer, they can perform typical urban firefighting tasks entirely on battery power for extended periods. The cab has a crew-focused approach. Seating is arranged to improve visibility, and the flat floor layout allows the firefighters to put on their protective gear more quickly. Touchscreen interfaces replace many traditional analog controls, which provide real-time system status, and those systems are designed to reduce the operator workload rather than automate any decision-making. Noise reduction here is another practical advantage. The electric operation significantly lowers noise levels during response and on scene. That helps improve communication between crew members and reduces stress in the residential areas. This has been cited by early adopter fire departments as a meaningful operational benefit rather than a cosmetic feature. The Rosenbauer RT is currently in service in fire departments around Europe and North America, though it's still being adopted gradually. Long-term durability and life cycle costs are continuing to be evaluated, and Rosenbauer has acknowledged that electrified firefighting fleets are still an evolving concept. It's not experimental nor speculative, it is in daily use, and by combining electric propulsion, advanced vehicle control systems, the Rosenbauer RT is one of the most advanced municipal trucks currently in service anywhere in the world. Number 11. The Bronto Skylift F112. The Bronto Skylift F-112 HLA, besides being a mouthful, is one of the most advanced aerial firefighting vehicles ever placed into service, designed specifically for operations at extreme heights. It's manufactured by the Finnish company Bronto Skylift. It holds the distinction of being one of the tallest firefighting aerial platforms in the world. When fully deployed, the hydraulic boom system can reach heights of up to 112 meters, allowing firefighters to access areas well beyond the capabilities of conventional ladder trucks. This kind of height makes it suitable for firefighting and rescue operations on some of the tallest buildings where interior stairwell access may be compromised or unsafe. The vehicle's boom system is fully computer-controlled, and it consists of multiple telescoping and articulating sections. Inputs are processed in real time to ensure the platform remains within safe limits. If unsafe parameters are detected, movement is automatically restricted, which prevents any structural overload. This kind of automation is essential at these extreme heights where even small errors can have serious consequences. At the end of the boom is a large rescue cage capable of carrying multiple firefighters and evacuees. The cage includes integrated water monitors that will deliver high-capacity fire streams directly onto the upper floors or building facades, and it allows crews to attack fires externally while minimizing exposure to heat and smoke inside. The vehicle uses advanced outriggers that extend and level themselves automatically, adapting to the uneven terrain and restricted spaces. Bronto's control systems will allow partial deployment configurations when space around the truck is limited, though operating height may be reduced under these kind of conditions. This vehicle is not intended for routine firefighting due to its size and cost. It's typically deployed as a strategic asset rather than a first response vehicle. And because operations at these extreme heights are inherently hazardous, training requirements for it are extensive. Operators have to be certified in both driving and aerial control systems, and departments rely on strict guidelines rather than improvisation. The Skylift F-112 is considered advanced not because it replaces any traditional firefighting method, but because it extends them into environments that would otherwise be inaccessible. Its proven deployment in real urban settings makes it one of the most technologically advanced aerial fire trucks currently in service anywhere in the world. Number 10. The Pierce Volterra Electric Pumper. The Pierce Volterra Electric Pumper is one of the most advanced structural fire engines currently in service. Built by Pierce Manufacturing, a long-established American fire apparatus builder, the Volterra is a battery electric fire engine designed to perform full structural duties while reducing emissions, noise, and mechanical complexity. Unlike experimental vehicles, the Volterra electric pumper has entered active service within multiple fire departments in the U.S. It is built to meet the same standards as conventional diesel-powered pumpers, including water flow rates and hose capacity. But the electric drivetrain is paired with a large onboard battery system and backup diesel generator that functions as a range extender. This propulsion system provides immediate torque, which does improve acceleration from a standstill, allows the truck to reach emergency speeds quickly while maintaining a smooth handling. The battery system is positioned low within the chassis, which will lower the vehicle's center of gravity, which improves its stability and handling. The firefighting systems on the Volterra are electrically driven rather than mechanically linked to an engine. The pump, compressors, and auxiliary systems operate independently of vehicle speed, which allow precise control of water flow and pressure. This also reduces wear on mechanical components and simplifies maintenance compared to traditional power takeoff systems. The cab layout does emphasize visibility and communication with digital displays that provide real-time data. Battery charge levels and pump performance data and noise levels during response and on-scene are significantly lower than diesel engines. One operational advantage of the Volterra is the ability to operate in enclosed or sensitive environments. Departments using the vehicle have noted improved conditions for both crews and civilians during an incident. If the battery charge drops below any operational threshold, the generator will automatically engage to maintain power. That system is not intended to replace the charging infrastructure, but to ensure reliability under unpredictable conditions. And while electric fire trucks are still relatively new, Pierce has been clear about the limitations and performance parameters. Long-term life cycle data is still being gathered, and departments evaluate adoption based on operational needs rather than assumptions. The Volterra doesn't rely on speculative technology or untested concepts. Instead, it represents a verified evolution of the traditional fire engine, combining established performance with modern propulsion and controls. Number 9. The Ziegler Z-Class Z8. The Ziegler Z-Class Z8, lots of Z's in that one, is one of the most advanced airport firefighting vehicles currently in service. It's manufactured by Albert Ziegler, a German firefighting equipment company with over a century of history. The Z8 represents the high end of European ARFF vehicle engineering. The Z8 is an 8x8 vehicle built on a purpose-designed chassis rather than a commercial truck frame. This allows it to carry extremely large quantities of extinguishing agents while maintaining stability at high speed. Depending on the configuration, it can carry about 14,000 liters of water, 1,700 liters of foam concentrate, and up to 250 kilograms of dry chemical powder. This multi-agent capability allows crews to adapt quickly to different conditions, particularly fuel-based aircraft fires. Despite its mass, though, the vehicle is capable of rapid acceleration and some good high top speed, allowing it to meet international airport response time standards. The drivetrain and suspension are all engineered for both paved runways and uneven ground near crash sites. The firefighting systems on it are electronically controlled and they're fully integrated into the vehicle's systems. A high-capacity roof-mounted monitor delivers water or foam at rates exceeding 8,000 liters a minute, while a front bumper monitor provides close-range suppression. Operators can control these systems from inside the cab using joystick controls and digital display, and crew protection is a major focus here. The cab's reinforced and designed to protect the occupants from heat and impact and even rollover forces. Some configs also include some underbody protection systems designed to shield the vehicle from burning fuel on the ground, so reliability and serviceability are emphasized throughout the design. Ziegler also designs the Z-Class with modular subsystems, allowing maintenance and repairs to be carried out efficiently between any deployments. The Z8's not intended for municipal firefighting due to its size, but it's a specialized vehicle designed for environments where aircraft size and their fuel load demand extreme firefighting capability. The Z-Class Z8 from Ziegler stands among the most advanced fire trucks in the world. It's got a combination of speed, agent capacity, and system integration, and it reflects the highest current standards in airport firefighting vehicle design. Number 8. Iveco Magirus Dragon X6. I mean, come on, the name Dragon X6? This thing is awesome. It's one of the most advanced heavy rescue and structural fire engines in active service within European fire brigades. Developed by Magirus in partnership with Iveco, the Dragon X6 is designed for demanding industrial firefighting operations. It is widely used across Europe by professional fire services that operate in a dense city environment. Now, the Dragon X6, besides having an awesome name, is built on a robust multi-axle chassis and configured as a multifunctional fire engine rather than a single-purpose apparatus. It carries a substantial water tank, about 4,000 liters, along with foam concentrate and a full complement of firefighting equipment. High-output pumps will allow sustained water delivery suitable for large building fires and industrial incidents. One cool feature is the integrated digital controls. Pump operations, vehicle diagnostics, and the equipment status, they're all monitored through a centralized control panel, and firefighters can manage water flow, pressure, and foam mixing with precise control rather than manual valves. The vehicle uses advanced suspension to maintain control under load and while cornering at speed. All-wheel drive and selectable traction modes also allow it to operate effectively in weird conditions like snow or debris-covered streets or even industrial sites, where these capabilities are essential for European cities. The cab is designed to accommodate firefighters wearing full protective gear with seating layouts that will improve their communication and visibility at a scene. The equipment compartments are arranged for rapid access, reducing the time required to deploy hoses, tools, and breathing apparatus. Unlike experimental or maybe concept vehicles, the Dragon X6 is fully operational and in daily service. Its systems are based on proven technologies that are adapted for firefighting rather than automation or where Magirus documentation doesn't specify performance. Departments will rely on standardized operational limits and training rather than assumptions here. The X6 is considered advanced because it combines heavy structural firefighting capability with modern controls and safety systems. It is a mature evolution of the traditional fire engine, and it's been optimized for the realities of modern city firefighting rather than specialized or rare scenarios. Moving on to number 7, the Scania P500 XT Heavy Rescue Fire Engine, Sweden. The Scania P500 XT Heavy Rescue Fire Engine. Oh my god, what a mouthful. It's one of the most advanced fire trucks currently used by European fire services. Built on Scania's XT off-road capable chassis, this vehicle is designed for incidents that go beyond standard fires, including major traffic collisions, industrial accidents, tunnel incidents, and even in extreme weather events. At the core of the P500XT is a high-output diesel powertrain. It produces about 500 horsepower. Now, this power is not intended for speed, but to support heavy payloads and towing capacity, and even stable operation under demanding conditions. The chassis got reinforced suspension, selectable all-wheel drive, and a high ground clearance, which allows the truck to reach incidents in snow, mud, or even floodwater. A typical configuration includes a water tank in the range of about 3,000 to 5,000 liters, foam concentrate storage too, and a high-capacity pump, which is capable of sustained water delivery for a large structural or vehicle fire. Unlike the highly specialized ARFF trucks, the Scania P500XT has firefighting capability with technical rescue equipment. Hydraulic cutters, spreaders, lifting airbags, winches, and stabilization systems are all carried on board, enabling the crews to perform complex extrications and structural support operations. Electronic stability control and advanced vehicle control systems are a defining feature. Traction management, braking assistance, they're integrated into improved safety during an emergency response. Fire services report that those features reduce the risk of rollover or loss of control during a high-speed response or even off-road movement. So the cab is designed with crew efficiency in mind. Seating layouts allow the firefighters to put on their breathing apparatus en route, and digital displays provide real-time information. Where performance limits apply, like maximum water flow under certain conditions, manufacturers and departments rely on clearly documented specs. So one reason the P500XT is considered advanced is its adaptability. Departments configure the vehicle to meet regional risk profiles, whether that involves wildfire response, industrial firefighting, or large-scale operations for rescue. This modular approach allows the same base platform to serve very different operational roles. The Scania P500XT is not the largest fire truck in the world, nor the most specialized, but it can combine power, mobility, and digital safety systems and rescue capability into a single vehicle. It represents a modern approach to heavy rescue firefighting that's grounded in real use rather than experimental tech. Number 6. Tatra Force 8x8 Fire Engine in the Czech Republic. The Tatra Force 8x8 fire engine. This is one of the heavy fire trucks used in environments where terrain and access conditions are severe. It's manufactured by Tatra Trucks, of course, in the Czech Republic, and the Force series is built around their distinctive central backbone tube chassis and independent swinging half-axle suspension system. That's a mouthful. This design gives the vehicle an exceptional off-road mobility and stability compared to conventional ladder-frame trucks. Now, this configuration allows them to carry large volumes of water, often exceeding 8,000 liters, along with foam concentrate and firefighting equipment. The high-capacity pumps here enable sustained water delivery, which makes the vehicle suitable for large rural fires and industrial sites. The suspension system is pretty cool. Each wheel will move independently, which maintains ground contact over uneven terrain, and that improves traction and reduces stress on the chassis. Fire services operating in mountainous regions, forests, and military installations have adopted this platform specifically for this capability. The cab and body are designed for some harsh operating environments. Armored-style cab construction is available for applications that involve wildfires or industrial hazards, and filtration systems will protect occupants from smoke, dust, and airborne contaminants. Operators can control firefighting functions through the electronic panels rather than manual valves, which does improve their precision and reduces fatigue during extended incidents. These systems are designed to function reliably, even in extreme temperatures, which, of course, is a key requirement for regions with harsh winters or even desert climates. The Force platform is widely used by both civilian fire services and military emergency units, and while documentation clearly defines the operating limits, particularly regarding weight distribution and off-road angles, departments rely on training and established procedures. The 8x8 Tatra Force is considered advanced not because of automation or even the novelty, but because its proven engineering of mobility and durability. It allows fire crews to reach and operate in places where conventional engines cannot. Number 5. The Rosenbauer AT Fire Engine. The Rosenbauer AT, which stands for Advanced Technology, is one of the most modern municipal fire engines. It's manufactured by the Austrian company Rosenbauer. It's designed as a next-generation replacement for the traditional structural fire engine. Unlike older fire engines that rely on an adapted commercial truck chassis or layout, the AT was developed with a clean sheet design approach. The cab is built around a flat floor concept, allowing firefighters to move inside the vehicle a little bit more easily and don their protective gear, and this layout will improve the crew readiness and reduce response time. All seating positions here are integrated with breathing apparatus mounts, a feature increasingly standard among professional fire services. It supports multiple configurations, including diesel, hybrid, and fully electric variants, depending on the department requirements, and while the electric RT variant is covered separately, the core AT platform remains advanced through its modular drivetrain options. Typical configurations include water tanks that range from about 1,500 to 3,000 liters, foam concentrate systems, and high-performance pumps capable of delivering over 3,000 liters a minute. The pump controls here allow precise regulation of flow and pressure, which will reduce operator workload. Touchscreen interfaces provide real-time information on pump status, water levels, vehicle diagnostics, and equipment deployment, and those systems are designed to assist the firefighters, not replace decision-making. Safety is addressed through reinforced cab construction. The cab reflects modern commercial vehicle standards that are adapted specifically for emergency response. The AT's low step-in height and wide door openings also reduce injury risk during rapid entry and exit. The Rosenbauer AT is considered advanced not because it introduces any new experimental tech, but because it modernizes nearly every aspect of the conventional engine using proven systems. This adoption by frontline fire services shows that it delivers measurable operational benefit without compromising its reliability. Number 4. Mercedes-Benz Unimog U5023. Mercedes-Benz, they've got one called the Unimog U5023 firefighting vehicle. It's one of the most advanced off-road fire trucks. It was designed specifically for environments where access, terrain, and weather make conventional engines impractical. Built on the Unimog platform, the 5023 is used by fire services, civil defense units, and military emergency responders. Now, its defining feature is the extreme off-road capability. It uses portal axles, permanent all-wheel drive, and locking differentials that allow it to travel over deep mud, sand, and snow, and even steep gradients. This makes it really suitable for wildland firefighting, rural response, disaster relief, and even industrial sites located far from paved infrastructure. Their water tanks typically range from 2,000 to 4,000 liters, high-pressure pumps, roof-mounted or bumper-mounted monitors, and while this capacity is a bit smaller than that of urban engines, it shows the role as an access-focused platform rather than a hydrant-dependent pumper. The cab features reinforced construction, high ground clearance, and sealed systems that allow limited water fording. Certain variants often include heat-resistant bodywork and filtration systems to protect the firefighters from smoke and airborne debris during wildfires. And while modern safety features like ABS and traction control are present, the capability here is rooted in its design. This is intentional, as the vehicle is often deployed in remote areas where maintenance support may be limited. The Unimog U5023 is considered advanced because it allows firefighters to operate where the other vehicles can't reach. It's got mobility, firefighting functionality, and low-standing operational reliability. It's one of the most capable specialty fire trucks in the world. I mean, of course, it's Mercedes-Benz. Number 3. The Vulcan Lion 8x8. The Vulcan Lion 8x8. God, these engines have some of the best names. It's one of the most advanced airport firefighting vehicles currently in service. The Lion series is built to meet strict FAA guidelines for aircraft rescue and firefighting. The 8x8 configuration represents the top end of Vulcan's lineup, and it's deployed at major airports where maximum agent capacity and rapid response is essential. Now, the Lion 8x8 is built on a purpose-designed chassis rather than a commercial truck platform. It's able to carry huge quantities of agents while maintaining stability at speeds. Typical configurations include about 15,000 liters of water, over 1,800 liters of foam concentrate, and dry chemical powder systems. This will allow a crew to address fuel fires, cabin fires, and composite material fires using the most appropriate agent for each scenario. The drivetrain and suspension, they're all optimized for paved surfaces while retaining limited off-road capability for rough terrain near the crash site. A roof-mounted turret will deliver high-volume water or foam streams, while front bumper turrets will allow suppression during the approach. Operators control these systems from inside the cab using a joystick and digital interface, which enables some accurate applications while the vehicle's moving. And the pump systems, too, are designed for continuous operations at high output. Crew safety, of course, is a major focus in the Lion's design. The cab's reinforced for impact and rollover protection and includes heat-resistant materials. Some configurations also include underbody protection system to reduce the exposure to ground-level fuel fires. The Vulcan Lion is heavily specialized. It's not intended for municipal firefighting. The size and cost of it and the operational role will restrict it to airport environments. Within that role, though, it's a proven and widely used platform, rather than an experimental design. The Lion 8x8 stands among the most advanced ARFF fire trucks in the world. It reflects the current state-of-the-art in airport firefighting vehicle design. Number 2. The Morita MVF Fire Engine. The Morita MVF, or Multi-Volume Foam Fire Engine, is one of the most advanced municipal firefighting vehicles developed for dense urban environments. Built by Morita Holdings Corporation in Japan, a company with over a century of equipment experience, the MVF is designed to address the unique challenges of Japanese cities, including limited space, high population density, and strict safety standards. Its defining feature is the compressed air foam system, the CAF system, which allows the engine to generate foam with adjustable expansion ratios. This will enable firefighters to tailor suppression methods to different fire types, including structural fires, vehicle fires, and industrial incidents. Compared to traditional water streams, CAFs can improve extinguishing efficiency while also reducing water usage and runoff. Despite its relatively small footprint, though, compared to large Western engines, it does carry sufficient water and foam concentrate for initial attack. High-efficiency pumps and electronically controlled foam proportioning systems ensure consistent performance under varying conditions. Crew safety and ergonomics, of course, receive significant attention. The cab's designed to accommodate firefighters wearing full equipment, with seating layouts that improve their communication and visibility, and equipment compartments are organized for rapid access, which reflects the importance of speed in this urban firefighting. The Morita MVF is widely used by fire departments across Japan, and it's also been exported to Asian markets, and it's considered advanced because it integrates modern foam tech, digital controls, and urban-focused design into a compact and reliable fire engine. Number 1. The Rosenbauer E-Panther Electric ARFF. The E-Panther by Rosenbauer is one of the most technologically advanced fire trucks ever built. It was developed by Austrian manufacturer Rosenbauer. This is the first fully electric airport rescue and firefighting vehicle to enter real-world service at major international airports. It's not a concept vehicle or experimental prototype, but a production-ready fire truck designed to meet the same stringent safety and performance standards as conventional diesel-powered vehicles. Rosenbauer retained the Panther's proven chassis, cab safety structure, firefighting systems, and layout while completely re-engineering the drivetrain and power systems. At the heart of the E-Panther is a high-capacity battery electric propulsion system. It uses multiple electric motors to drive all axles, which provides full-time and all-wheel drive and extremely high torque. This is important for ARFF operations where vehicles have to accelerate rapidly while carrying loads that can exceed 30 metric tons when fully equipped with water, foam, and chemicals. The battery system is designed to support typical aircraft response profiles, which involve short, high-intensity driving bursts followed by extended stationary firefighting. During incidents, the E-Panther can operate its pumps, monitors, lighting, and onboard systems entirely on electric power, and this is valuable in aircraft fire scenarios where smoke, fumes, and confined spaces already create severe visibility hazards. Now, the capability of the E-Panther is equivalent to that of the conventional Panther models, and depending on the config, the vehicle can carry more than 12,000 liters of water and substantial quantities of foam concentrate and dry chemicals. All the systems that suppress fuel fires, cabin fires, and composite material fires are integrated into the vehicle's electronic control architecture and can be operated from within the cab using joysticks and digital interfaces. Crew safety, ergonomics, they remain central to the design. The cab retains the reinforced structure of the Panther platform, including rollover protection, and optional thermal imaging and infrared camera systems allow crews to detect fire sources and obstacles in smoke or darkness without exiting the vehicle. Airports do face increasing pressure to reduce their emissions and noise without compromising emergency readiness, and the E-Panther produces zero local emissions during operation and reduces noise during response and on-scene activity. Charging and range management are handled through high-capacity charging stations designed specifically for emergency vehicles. Airports deploying the E-Panther typically integrate it into mixed fleets to ensure redundancy and flexibility. Feedback from the early adopters has focused on its performance and integration into the existing protocols. While the long-term data on battery lifespan and maintenance costs is still being gathered, the vehicle's deployment confirms that fully electric trucks are no longer theoretical. The Rosenbauer E-Panther doesn't replace conventional vehicles overnight, nor is it marketed as a solution to any universal problem. Instead, it represents an operational step forward in fire truck technology. It shows that electric propulsion can be successfully applied to the largest and most demanding vehicles in service today. It is a real fire truck operating in real airports, performing one of the most critical emergency response roles in the world. And for these reasons, the E-Panther is widely regarded as the most advanced fire truck currently in service anywhere on Earth.